And then we do the context manager with open file read-only mode as F.
If you're an application support engineer or trade operations specialist in investment banking, you're in exactly the right place. And trust me, this is the insider knowledge most technologists never get to see. And now, here's Carlisle.
These are the representative of the lines in our fix log. Bunch of fixed messages. Now, before you start building any kind of program, whether you're building it in Python, whatever the language is, you need to be very clear on what you're trying to do. Don't just start coding and writing stuff, man. What are you building? What are you doing? What is your purpose? What are you trying to accomplish? Also, take into consideration some issues you might run into, certain concerns regarding security and performance. Have a structured plan. Measure twice, cut once, right? So we want to be very clear. What is it that we are trying to do? We are trying to convert a flat file, which is the fix log, into a Python format, something that makes sense, something that is efficient in terms of, let's say I want to do analysis, I want to parse, I want to look for how many orders, how many fills, I want to do a lot of different things. I need them in a logical format or structure, a data structure that Python understands. So here's my plan. I want to go from string, which is what this is going to be initially, because again, to Python, it doesn't understand tag, value pairs, equal sign. These are all just a bunch of characters in a flat file. When we bring it in, it's just coming in as a string. So we need to break this down piece by piece. First by the delimiter, right? We split on the pipe. Then we need to iterate or loop through each one of these tag value pairs per line. So for every line, we're gonna say, we're gonna grab the 35 and the D, the 55 and the IBM, the 38 and the 100, right? So we wanna grab each piece. We need to split them out. We're gonna grab the 35, grab the D, and then insert it into a Python dictionary.
When parsing data, your choice of data structures is critical. Dictionaries are perfect for tag value pairs because of the big O1 lookup time, but they can't handle repeating tags. Lists give you big O(n) lookups, but maintain order and allow duplicates. For very large data sets, consider specialized structures like default dict for nested data or ordered dict when preservation of insertion order matters. The right structure can mean the difference between a parser that scales to gigabytes versus one that crashes with a moderate load.
We're going to use a dictionary because that's perfect, because a dictionary is in this exact same kind of format. So basically a dictionary, the way you store data, first of all, you use the curly brackets, and then you have, like 35, and then the dictionary will be colon D. So that's your tag value pair, right? And then you have a comma. So you have, another one, you say symbol, 55, and then you say D, right? So that's the second item. So this is what the dictionary is going to look like. The items are the tag value pairs. That's what's in a dictionary. That is what we want to create. However, a dictionary, you have to have unique items. So this is not going to work. I'm going to explain that. Stick with me. I'll explain why that is the case when we get to it. But you cannot just put everything into a dictionary. So what we're going to do is we're going to contain this dictionary within a list. So ultimately what we're trying to do is create a list of dictionaries. Every single fixed message is going to be an entry in our list. So enough about me. Let's go ahead and get coding. So we're going to first of all build a function. So let me try to get out of the way here. So we're going to build a function. We're going to call it, fix parser. We're using PEP 8 standards here. So snake case. I'll tell you what that is in a second. So parser. And then we say, and actually, I need to have my coffee. So def fix parser. And then we're going to look for an argument called file. So pretty much, this is how we set up a function. A function basically being consider it a recipe. This is a recipe or a set of instructions that you use to build something, right? I'm going to call this function because I want some kind of product. And the way that that product is built is defined within the function. So the function is going to tell you how to do it, right? So whenever you call this function, it's going to do this stuff. That's whatever we write, that's what's going to happen, right? So First thing we need to do, so so we want to go ahead and start our function. So the first thing we want to do is we want to go ahead and do a doc string, but I want to keep this simple. We have limited space, but generally you want to do a doc string, basic explanation of what this does. I'm not going to get into that in this video. You can look it up, but you should have a good doc string here. But for the purposes of this limited space, I'm going to go ahead and just go ahead and get started. So we want to go ahead and open this file. So the way we're going to do that is we're going to use a context manager. So we're going to say with open, and then we're going to reference the file as F. So what we're doing is we're not actually opening the file. We're not touching the file yet. We are setting ourselves up in terms of how we're going to process this file. So what we do is we're setting up a file object. So we're creating a file object, which is going to be stored in memory. It's going to point to the file descriptor, and we are going to refer to this file as F. So we created this variable. This could be anything. This could be P, L, M, N, O, P, whatever it is. I'm using F. This is just a variable. You could have used whatever you wanted to. File, of course, is the file, the argument. Whenever you call this function, you're going to give it an argument. The argument is the file name. So I'm referring to the file here. So one thing that we want to do is that the default mode, when you use this context manager, and I explain what that means when I say context manager, is the read mode. So I don't need to actually specify it, but good practice to do so. So we have right here R, and we go as F, okay? So context manager, what's the big deal? The big deal is that this is going to automatically close files when you're done with it. You're opening up the file to do a certain task. So it's like I'm giving you instructions on how to take something out of the oven. And I say, with your gloves on, take the pie out of the oven. Pretty simple, right? The reason that you're putting the gloves on is to take the pie out of the oven. So you know, once you take the pie out, you get rid of the gloves. The purpose of the gloves is to do the specific task. The purpose of the open is to do what comes next. Once you're done doing that, close the file. We want to be conscious of open files. You don't want to, you're in a production environment, especially high-speed trading or high-frequency trading, where, you're processing large log files, gigabytes and gigabytes of log files, thousands of lines. You start opening this file, opening that file, opening this file, and then you forget to close it, and then you can get errors in terms of too many open files. So you want to definitely make sure you are closing your files quickly. But this will do it for you automatically, so you don't have to worry about it. Use a context manager with open file, read-only mode. Of course, you have write mode and other modes as well. The default, again, is read-only, but you should specify it so it's clear what you're doing. This is good practice. So we're setting up to open the file. We haven't actually touched the file yet. So now what we want to do is we're going to move on to the next level. So we have this link to the file. So now what I'm going to go ahead and do is I am going to, what we need to actually start doing is we need to start ingesting the lines from the log. Line by line, process the first line and parse. Process the next line and parse. So you pull in one line, parse it. Pull in the next line, parse it. So we want to start up this lazy process. This is memory efficient, and that is very key. We don't want to load up the whole file into memory. Again, in a production environment, you could have large logs, which take a lot of space. So we want to do it line by line. This is the way to do it. So to do that, what we're going to do is we are going to use a for loop. So a loop, let's do the loop first. So for line in F. So this is another piece of Python magic. This is another example of why Python is so awesome. By the way, if you're enjoying the video, click on the like button and subscribe if you haven't subscribed already. It's free. Anyway, so let me tell you the beauty of this. I'm gonna tell you a secret. A lot of people are programming and they know, oh, I do for loops, but they don't actually understand how it works under the hood. For line in F is really a shortcut. This is a shortcut because you're doing Python. You're not doing some compiler-based language, C++, where you have to do every single thing. This actually is starting up a lot of more complex code behind the scenes so you don't have to. So one of the things that this does is it initiates a dunder method. Dunder method is, if you ever see those things with a double underline, that's why they call it dunder. So one of the things it's calling is iter and it's also calling, I believe, next. So there's some coding that is happening behind the scenes. And the benefit of that is basically, I look at for loops as a machine, right? Think about the paddle on a paddle boat. It's spinning in a circle. Every time it gets to the bottom, it hits the water. It does another revolution, hits the water. Does another revolution, hits the water. In programming terms, iteration. Every iteration is every cycle. Every time it hits the water, boom, and another one. And another one, and another one. So that's the basic idea. Whenever I say for line in or for something in, what I'm saying is I want something. What I want is line. Line is a variable. I could have called it cars. I could have called it dinosaurs, whatever it is. This is just a variable, right? It's a container to store something that I want. Now, the thing that I want is coming from F. F, remember, is how we created a link to the file. We open the file as F. So F is a file object pointing to our fix log. So the source of this product is going to be the file. Now, let me give you an example of a real world loop. Get outside of the programming world. I know you're learning and some of this stuff is a little scary. Trust me, it's not as scary as you think it is. This is really easy. You just have to take the time to understand. And I'm gonna help you do that. So let me give you an analogy. So an actual loop in the real world would be like, imagine we had a whole bunch of boxes behind a truck. Now, there's a limited amount of boxes. There's a specific number. It might be 10 boxes, 15 boxes. Now, what I want from you is, I want you to load the truck. That's the task. That is the product. I want this truck loaded up. So for loading the truck in the boxes, when you do the for loop, the basic idea is you have a list of items that you're going to be doing the same thing over and over to. So the task is to load the truck. So you grab a box, load the truck.
Grab another box, load the truck. Grab another box, load the truck. Grab another box, load the truck. Grab another box.
Okay, you get the idea. So what happens when you run out of boxes? When you run out of boxes, you stop. The amount of times that you're going to do the task is based on the amount of items. So in this case, remember, F is linking to the fix log. The fix log has a finite number of lines. Let's say it has 100 lines. So 100 lines, 100 boxes. You get to the 100th line, there's no more lines, then you stop automatically. So we're going to loop through and do whatever I say next. We're gonna do that until we run out of lines. Take a line, do something. Take a line, do something. Now, something else, advanced notes for you to take. These are things that you should understand and look into. You have something called big O notation. Big O notation gives you the time complexity of a task. So in this case, we're gonna be M times N complexity. And what that means is what we're doing, what it takes to get this done is going to involve every line, so the total number of lines, multiplied by the number of tag value pairs. Because for every line, we're gonna have to process the line, split it up by the delimiter. But then we're gonna also, for that same line, have to do an amount of operations that is equivalent to the amount of tag value pairs. Each tag value pair, we're gonna do something with. We're gonna split it by the equal sign. So that is the time complexity that this is gonna have. That's something to look into. Look into it. Big O.
Let me break down big O notation in a way that's practical and usable in your day-to-day coding. So big O, what's the big deal? It's not just some academic concept that professors use to torture their students. It's actually a really powerful concept. Think about this. You're building a trading platform, right? So you write some code that works really great with 10 messages. You get a cookie. Everything's so smooth. But then you put it into production and all of a sudden you've got 10,000 messages flowing through and the whole thing crashes and burns. What happened? That's where big O comes in. It's like a crystal ball that allows you to predict the future of your code. When I say big O1, what I'm saying is, hey, no matter how many items you throw at this thing, it's always going to take the same amount of time. That's your dictionary lookups. Super fast, super consistent. When I say big O(n), I'm telling you it scales linearly over time. It scales linearly with your input size. So if you have 10 times more messages, it's going to take 10 times longer. Not terrible, but you need to plan for it. When you get to big O n squared, that's when things get scary. That's when you've got a loop inside a loop, like we did in our parser. Inception, basically. Double the input and you quadruple the processing time. This is where systems fall apart in production. Here's a real-world example. Let's say you're parsing a fixed log with 1,000 messages, each with 20 fields. With a nested loop approach, that's 1,000 times 20, which is 20,000 operations. Takes maybe half a second. Not bad. High-frequency trading guy in the corner says, hold my beer. But what happens during a volatile trading day when you've got 100,000 messages? Now we're talking 100,000 times 20, which is 20 million operations. That could be 50 seconds of processing time. In trading, that's an eternity. So when you're writing code, constantly ask yourself, what's the big O here? How will this hold up when the market goes crazy? If you see a nested loop, that's a red flag. If you're using a list when you could be using a dictionary, that's a red flag. Big O isn't just some theoretical thing, it's an early warning system. It tells you where your code is going to break before it actually does. And in a trading system where every microsecond counts, that's not just nice to have. It's the difference between making money and losing it.
All right, so here we go. Ready to start the machine. Remember, this is a cyclical machine. We're doing a task over and over again. So here is what we want to do. This is what I want this program to do when you call this function. So for line in F, so first thing we want to do is split it up by the delimiter. So let's go ahead and say line equals line dot. And now we're going to say, we're going to call a string method. So just to be clear, when we pull in a line right now, and this is very important. Let's pause for a second. Very important concept for you to understand when you're dealing with parsing. You need to be very clear on what your data structures are. As you parse through, you're going to be changing from strings to lists to dictionaries, back and forth. If you're not clear what your data structure currently is, you're going to run into problems. For example, what I'm about to do is applicable only to strings. If this was not a string, I would get an error. This would not work. I'm about to do a string method. So consider that to be an action that you can do on a string. What I want to do is I want to remove the leading and trailing spaces. So that if there's an extra space in the beginning of the line or the ending, I want to cut that off. That's the action that I want. That action in terms of Python, in terms of doing that to a string, is called a strip. That's the action I want to do. So the way that you do a string method is you dot it. You dot the thing. Line, when you pull this line in from my for loop, it's just a string. It's going to be tag equals value, pipe, tag equals a value. There's no division. It's all one thing. Now we're going to break it up. We're going to break it up using a string method. So we say line dot strip. So line dot strip, and we just put a empty parentheses. That's going to split it up. I'm sorry, that's going to clean off the leading and trailing space. Now you can actually chain methods together. So I'm going to line dot strip dot split. So a split, basically what that does is we're going to break it up by a delimiter. So I'll explain what that is. So what we're going to do here, we'll put in quotes the pipe. So now what we're doing is we're breaking this up. We're going from a string, which is just the whole line, to basically it's a list of strings. So the list that we're building is going to contain 35 equals D, first item. Next item, 55 equals IBM. So now we're breaking it down into logical components instead of just having everything all as a string and everything's the same. So that is how we're breaking it up. So I just want you to see what that looks like. So as a list, when we do this operation, this is what the result is going to be. So you're going to see that you have a list with multiple items. And the items are going to be 35 equals D, and then 55 equals IBM. So you get the idea. So that is going to be the result of this. So now we are dealing with a list. So line is now a list. And notice what we did here. The way that we modified line, we said this is what line is. I'm gonna tell you, you don't tell me what line is, I'm gonna tell you what line is. Line is line. I know it sounds weird, but it's not line is line, it's line is line modified. Line is itself modified with these methods. So I'm saying whatever line is, so for example, in the first iteration, the first cycle, the first time this loop runs through, we grabbed this line. So I'm saying that this line equals this line, so 35 equals D, blah, 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 stripped, so we remove the spaces, and split by the delimiter. So boom, 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 now we end up with this. We have the tag value pairs in a list. So now we need to get deeper. We need to get deeper. We need to get down and break down the actual pairs themselves. Now, one thing to note, we don't want the pipe. We don't need no stinking equal sign. That is fixed stuff. Ultimately, what we want is the most important part of the fixed message, which is the stuff that has meaning. Equal sign has no meaning. Pipe has no meaning. That's a formatting thing. That's a syntax thing. The meaning of the fixed messages comes from the tags and the value. So 35 is what we want. D is what we want. So get your minds out the gun. Anyway, so basically, what we need to do now is we've broken it up by delimiter. So now we need to get down to the granular level. We want to get the 35 and the 8. We want to pull those fields out. So I'm going to show you how we do it. So what we're going to do is we're actually going to do what is called a nested loop. But before we do that, we need to keep track of what we're doing here. We want to put each line into a dictionary, right? We want to store the line in a dictionary because this formatting is very compatible. Tag value pairs in Python dictionary, it's key value. So if we're going to put it in a dictionary, we need to actually create a dictionary. And we also need to create the list that we're going to put all this stuff in. So that's something we actually forgot to do. So let's actually see. We don't want to do that at the end. So we'll do that. So just imagine this is right here. I'm going to squeeze this in. So we will go ahead and say log, sorry about this being so small, log equals square brackets. That's how you create an empty, so we're creating an empty list. We want to take all of these messages, convert them into dictionaries. Each message is a dictionary. And now we take all of them and we store them in a list called log. That is the ultimate product that we want to deliver here. So we have to create that empty list. So now that we have the empty list, the next thing we need to do is we need to create an empty dictionary to store the line, the current line that we're working on. So what we're going to do here is we're going to go ahead and we're going to say, we're going to call it message. I'll tell you MSG. So MSG equals, and then we'll just do curly brackets. So that's the symbol for a dictionary. So we're just creating an empty dictionary. So now we have a place to store this so we can insert it. So again, back to the analogy of the boxes. Imagine we are building a product. So the product is going to be delivered in a box, right? When you buy something in the store, it comes in a box. So the box in this case is our list. So ultimately, the product is coming in this list called log. So we have this list called log that's going to have all the fixed messages. Now, whenever you buy something, a lot of times it comes in separate packages inside of it. You have there might be a power cord in a bag or something like that. So that is what would represent like the dictionary. So the dictionary is sort of a virtual bag for the individual pieces. So this is a box. We're creating a box of fixed messages, right? And each fixed message is stored in an actual dictionary. My cat here is actually on my eye. I'm trying to do a video, trying to show you guys how to do a parsing function. And this cat, you. Anyway, so we created an empty dictionary to store the line. So let's go ahead and continue. So now what we want to do is we want to do what's called a nested loop. So that is a loop within a loop. So the first loop is every line. First line, do something. Second line, do something. Remember, the loop is a machine. Every time you go and you're grabbing from F, the file object, grabbing a new line, bring it in, split it by the delimiter. Chop, 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 chop. You got a list of tag value pairs. Now, that individual line, you need to iterate or loop through each tag value pairs. So we're gonna loop within the line that we're using. So that's what we talk about when we say a nested loop.
Let me illustrate to you how a nested loop works. First of all, thank you for clicking on the like button and a comment below. Really appreciate it. It really helps the channel if you watch the video and enjoy it and it helps you. Let's explain how a nested loop works. So first of all, we have a series of cups for our outer loop. 3 items. A cup is an item. And now we have the inner loop. We have 3 grains of cereal. So for people who watch my video, did not click on the like button, I did not comment, even to say an angry comment, this is what I'm going to do to them. I'm going to capture them, and I'm going to do a nested loop on them. The loop is as follows. For every day, we're going to grab a cup. That is our outer loop, right? For each cup, I'm going to put 3 meals in the cup. Breakfast, lunch, and dinner. That is one full loop. The putting of the grains in the cup is the nested loop. That is the repeated task that I did per iteration, per cup. So let's see that again. For cups, in cups, right? For item, in flakes, right? So now here's the inner loop. Grab a flake, put it in a cup. Grab a flake, put it in a cup. Grab a flake, put it in a cup. So I just did I miss one? Or the X bonus flake for you guys. So I just did a loop. But this loop is in the context of an outer loop. The outer loop is this one cup, right? For cup, in cups. For meal, in flake. So imagine that these are items in a list. And with the loop, every iteration, we're grabbing a single item, doing a single task or a series of tasks, placing it in the cup, and then we repeat. Go back to the list, grab another item, do a series of tasks, then go back to the list, grab another item, do a series of tasks. There's no more items, so the loop is complete. And since this is the inner loop, and there's no more loops, there's nothing else to be done, we are complete. Here is the end product. This is ultimately what we wanted to produce. We have produced 3 cups containing 3 flakes each. That is how nested loops work. And this is going to be all you're going to be eating for an entire day for the sin of enjoying this video and not even bothering to click on the like button or providing a comment, whether positive or negative. Seriously though, guys, it's actually very important. The algorithm relies on you to tell it what's valuable and what's not. The algorithm can't read your mind. If you enjoy this video, it's helpful for you, but you don't engage, you don't like, and you don't comment. It's not for my ego, it's for the algorithm. The algorithm needs a signal to know that this is good content. If you see something and you like it, it helps you engage, and that will inspire more of that content being created for you through your support. Let's continue.
So what we're going to do here is we're going to go ahead and say for, what do we want? Remember, with the for loops, you start with the thing you want and then the source of, what you're going to feed that with. So what we want is, I want the fields. I want the 35 equals D, 55 equals IBM. I want those things. So I'm just going to call it fields. For fields, and then we say in, what are we going to say in what? What's the source? Where can we get these tag value pairs based on what we've done so far? We can get it from the line. Line is the variable that we created that currently contains a list of tag value pairs, right? And we need to loop through. Remember, that's the way a loop works. So first iteration, we grab the first item. Second iteration, we grab the second item. Just like with the lines, the first loop was looping through the lines. First iteration, first line, second iteration, second line. Now we're looping through item 1, item 2. So it's item 1, do something. Item 2, do something. So now we need to go ahead and define that. So for fields in line, so that's our loop. That's our for loop. Of course, we have to put a colon, and always remember to indent. Very, very important. Indents are very, very significant in Python. Do not forget to indent. Whenever you see a colon like this, you know you're gonna have to do an indentation. So for fields in line. So now, what do we want to do with the line? Can you pause the video if you need to? In fact, I think you should pause the video. Stop and think, because we've just done this. We've done this before. You know enough right now to figure this out. What do we want to do next? For fields in line. So we're gonna bring in, so the boxes that we're loading on the truck is stored in this list, and the boxes are tag value pairs. So we pull in 35 equals D. What do we want to do with it? What's our goal? We want to get to the 35 and the 8. We don't want the equal. We want the 35 and the 8. We want the message type and the value. That's all we want. Get rid of the equal. That's garbage. Garbage. So what we're going to do? Exactly kind of what we did before. A little bit different. We don't need to strip again. So what we're going to do is we're going to go ahead and say, we're going to redefine fields. All right, so we're going to say fields. Sorry about the horrible doctor's handwriting. I apologize, guys. Now I'm writing P for some weird reason. Fields equals fields what? Fields, string method, right? These are strings stored in the list. String method, which string method? Dot strip, nope, split. So we're gonna dot split this, dot split, and we're gonna split it by what? What are we splitting by? We're gonna break this up by the equal. So I'm gonna put equal in quotes, and then we're gonna do something different this time, something special. I'm gonna set a limit of how many times you do this split operation. Why would you wanna do that? Why would there be more than one equal in a fixed message? You're a dummy. Actually, well, I'm not gonna debate whether I'm a dummy or not, but I do know why we're gonna set a limit here of 1. The reason we're putting this limit here is because in tag 58 in fixed messages, it is a text message. So tag 58 represents a text message. So the value of 58 is a text message. It could be anything. It could be like, hello world, how are you doing? Thank you for clicking on the like button. Thank you for subscribing to my channel. And by the way, my name is Carlisle, and Carlisle equals. So you get the point. The bottom line is you can put anything in there, including an equal sign. So if I don't specify or limit it by 1, it can split it multiple times. So that would be a problem. So we're setting a constraint of 1. Now, we are going to do something a little special. Whenever you write a program, you have to understand, unless it's some kind of fancy machine learning, whatever, this kind of code is stupid. It's got no intelligence. It can't think. So it's only going to do exactly what you told it to do. So you have to think about edge cases, situations that might come up that are unexpected. Don't write a program to just parse perfectly formatted fixed messages, not a corrupted file, not malformed messages. No, you have to build your program anticipating some strange things might happen, as they usually do.
So when I talk about edge cases, I'm talking about these outliers. Something unexpected, something hopefully very rare that can happen. It's a bit of an anomaly. Edge cases are like silent killers of production systems. In fixed parsing, these include malformed messages, missing delimiters, incorrect checksums, split messages, out of order sequences, and encoding issues. A parser that works perfectly in testing can crash spectacularly in production. Remember the 2010 flash crash? Systems failed to handle unexpected message volumes and formats. Always design defensively. Validate everything, fail gracefully, and log extensively. Your 3 a.m. self will thank you when alerts start firing because someone sent Unicode characters in a fixed message field that your system expected to contain only ASCII.
So for example, for some reason, you get a tag and not a value. So you get a 35 and not a D. What's that about? That's weird. But who cares what the reason is? The bottom line is, I don't want it to break my code. So what we can do is we can measure the item. Remember, these items are tag value pairs. So we can measure them. Actually, I'm sorry. We just split it by the equal sign. So let's update what we have as far as data. So the items in our list, So this is what we have now. We have now a list which contains 35. That's assuming we didn't run into any problems, which is the point I'm getting into right now. So if it was a good fixed message, we should have 35, comma, D, so the tag and the value separated. So this is a list with two items, a message, so message type, and I'm sorry, oh man, holy moly, message type and value. That's what we have, if there was no problems. But what if we only had a 35 and no D, for example? So I need to measure the amount of items in there. So I'm gonna show you something. This is something that you can use so many times in Python for so many different reasons. You can do a measurement. So what we're gonna do here is we're going to say, and we're doing the if, so we're gonna do a conditional. So we're gonna say, I want you to do something only if something is true. If it's raining, get your umbrella. If it's not raining, you're not gonna get your umbrella because I only said to get an umbrella if it's raining. So I'm gonna say to do something, but only if a condition is true. So the condition I'm looking for is if there are two items in fields. So I'm gonna measure fields. So we'll say if fields equals 2. I just did a typo. Did you catch it? Did you catch the typo that I just did? I put 2 equal signs because I'm a dodo brain. Actually, no. There's a difference in Python between equal and equal. We used equal a couple times to assign things. We created an empty dictionary that way. But what we're doing is a comparison. We want to say if field, so the value of field. Oh my. Actually, I did do a typo. I did do a typo, guys. I apologize. Holy, joke's on me. Trying to be funny, and the joke's on me. If len, I forgot to do the measurement. If len fields, now it's all tiny again. You know what's in there. If len field, so len, think short for length. So if the length of fields equals 2. So I'm saying if there's 2 items in here, I want you to do something. So with an if statement, you put the colon. So you know when you see a colon, you know what comes next? Indentation. So we're gonna go ahead and indent. And here is where we're gonna say what to do. The beauty of this is if there are not 2 items in the list, so there's not a tag and a value, it's gonna silently in the background just proceed. Oh, there's a 35 and there's not a D. Okay, whatever. Next. It's not gonna choke. It's not gonna complain. It's not going to put some garbage into your list that we're creating. It's just going to silently ignore it. The condition was not met. It doesn't have 2 items, so I'm just gonna move on. So in this case, if there are 2 items, these are the instructions. So can you guess what we need to do next? We have a list which contains a tag and a value. What do we need to do next? What we need to do is we need to go from a list containing 2 items, 2 strings. We want to go to a variable. We want to contain 35 as a variable and D as a variable so we can then insert it into the dictionary. So let's go ahead and I'm going to show you a snazzy way to do this. We don't want to write more code than we need to. So in one line, I'm going to create 2 variables and assign them. So basically, I'm going to create a variable I'm going to call key, which matches the dictionary. So dictionaries are key and value pairs. So I'm gonna create a variable called key and one called value. In key, I'm gonna put 35. In value, I'm gonna put D. So what we do in one line, we'll say key, comma, value. How much value did you get from this video? Well, click on the like button. How many times am I gonna say that? Anyway, key value, key, comma, value, and then we say in parentheses, we're going to say fields, and we put a bracket, and then comma, fields, running out of space here. Okay, we'll put 0 and 1. What does that mean? Index positions. So in this list, the first item is in position 0. We don't start from 1 just because. We want to keep it interesting. So we're not going to start from 1. We're going to start from 0. That's just how it is. So remember that if you're trying to target the first item in a list, it's going to be 0. Second item is 1. So 0, 1, 2, 3, 4, 5, 6, 7. So what I'm saying is I'm creating 2 variables, key and value, and I'm inserting into those I got to close my parentheses over here. When I'm inserting into the variables 2 things. I'm grabbing from the variable fields the first item. So that will be 35. So key is 35, or key contains 35. I'm grabbing from the second item in fields I'm creating a variable called value, and I'm inserting into that variable the second item in field, so that means D. So I'm putting D into a variable called value. So key equals 35 and value equals D. That's the result of this. So now we have a tag value pair. We pulled the two things. So now we can go ahead and insert. Actually, we're gonna loop through, right? We're gonna keep looping through, but every time we get a tag value pair, we're gonna go ahead and insert it into the dictionary. So we created a dictionary called message. So the way you insert into a dictionary is a little bit interesting. You don't do the normal thing where you say, message equals blah, blah, or something like that. The way you do it is you just simply say, so the dictionary is called message. So we say message, and then we put brackets, and then we say equals. So in the brackets, you put the key, and here you put the value. So we put the key that we want in a variable called key, keeping it simple. So key goes there, and value goes here. I know it looks a little weird, but just think about it this way. Remember what is in these variables. So key is 35, and value is D. So when I write this, what the interpreter sees is message, which it recognizes as a dictionary, and then it's seeing 35 as the key name, or the key value rather, and then it's seeing D as the value. So it's going to look and see. So this is a very, remember earlier I said there's an important thing you need to know about dictionaries. So it's going to look in message and see if there's a key called 35. If there is one, it's going to go ahead and put whatever value you have here into that position. See where there's a problem? If you have a fixed message which has multiple orders, so there's something called repeating groups. So you have one fixed message that has multiple orders. So within that line, there's multiple 35 equals Ds. Every time you find another 35, it's going to overwrite the last one. So if you have a 35 equals D, and then you get a 35 equals 8, the D is going to be overwritten with the 8. So you can only store one. Remember, dictionaries, that's some place you want to store something like, I was going to say social security numbers, but it's 2 items. So maybe you have a social security number and the person's name. So that's the key value pair. So you can't have the same person, multiple times. So you run into issues like that. So everything has to be unique. So in order to process a repeating group, you would need to add logic that recognizes the repeating group and then stores each message in a container of some sort. So you're going to be able to have, so you have one line that has, so this is representing one fixed message, and then within it, you have another data structure that contains first order, second order, third order, fourth order, right? So you would have to factor that in if you're going to deal with repeating groups. I'm just keeping things really simple here, but that's something you should look into. Look into fixed repeating groups, play around with this, and see what happens when you have the same tag 35 repeating, what happens there. So basically, this is a nested loop. So we have to remember, let me show you something. I want you to understand how this works. When we say nested loop. Nested loop, that's the machine, the paddle wheel going around, round and around we go. So basically, we have a for loop, which is our outer loop. So the outer loop is basically doing all of this, all this stuff that you see here, and then it's doing it over and over again. All this stuff over and over again. But every iteration, you also have this right here. So there's a nested loop. So for every iteration, this is also going to be done over and over again. So that's the basic idea. So basically, look at it this way. So for the first line, we're going to go ahead and do all of this. But one of the things that we're doing is when we get to this line, we're going to basically strip out the tag value pairs, strip it out. So we get them all out, insert it into the dictionary, and then start all over again. So we're looping over each line. So every cycle, it's a new line for this loop. Every cycle for this loop, it's a new tag value pair on that line. So that's the basic idea. I hope that makes sense to you. So anyway, Now what we need to do is, once it has gone through all the lines, and for every line, it's done all the tag value pairs, breaking it up. Now what we need to do is we need to populate what? What is the goal? What is the product, the end product that we're trying to deliver to our customer, which is the caller, whatever called this function, we need to deliver something to it. What is that product? The product is the list of dictionaries, log. We started this list here called log. So basically I need to put this, we just produced one of the items, which is a new dictionary with the first message. And now I need to store it into something. So basically we want to do for every iteration. So we are under the for loop, that's the indentation. So under that for loop, we're going to go ahead and say, we're going to do log. So log is a list. So now remember we did string methods. Now we're going to do a list method. String method, actions you can do on strings. List method, actions you can do on lists. So I want to modify this list in some way. So you remember how we did the string method, same syntax, dot method name. So this is a dot append. So we want to append. So I'm going to insert something into the list. So what are we inserting into the list? In parentheses, we go ahead and we put the item. What's the item? The dictionary. We want to put, this is going to be, the end product is a list of dictionaries. So we want to go ahead and put message in there. So the current message gets appended to our dictionary. So every cycle, every cycle, at the end of it, we're going to go ahead append to the list. So we have a new dictionary in the list, a new dictionary in the list, a new dictionary in the list. That's what happens at the end of every loop. Now, once we're done, when we no more lines, then we need to actually deliver this product to the caller. So when you call this function, whatever calls it wants something. You're not going to call this function for nothing. You want some kind of product. When you call this function, it's like you're placing your order for something. So you're sitting there with your hands out. Where's my item? What's my item? I want a list of dictionaries. Where's my list of dictionaries? If you just run this and you do all this parsing and then you put it in the log and then you just go home, like how is the person gonna get the thing they ordered? You need to return the product back to the caller. Right now, this is all existing within the function itself. We need a path outside of the function to go to, and you have to understand the idea of scope, where you have global scope and local. So local is within this function. So like these variables that I'm creating here are local to this function. So within this function, they make sense. Outside of the function, they do not. So the product that we are delivering here, a list of dictionaries, in here, it makes sense. I could continue and do more stuff with that list, but outside of this, it doesn't exist until you do a return. So we go to all the way to the first indentation here, and we do a return log. And that is how this all works. You do all this work, but how do you actually deliver the product? The way you deliver it is with the return. So that is basically it. Hopefully I didn't make any mistakes. I want to run through some more advanced concepts. We're not going to get too deep here. This is more introductory for people that are more beginner to, getting into intermediate. So when you get more advanced, here are some things that you have to consider. So one thing that we did not do is we didn't do something called a membership test. Remember, we talked about edge cases. We have to anticipate problems. Anticipate problems, there's always surprises, so you have to anticipate them. What if the line contains something that is not a fixed message? Ultimately, you want to create some kind of a function that is able to recognize fixed messages and probably validate the fixed standards, in terms of there's required tags. And so you want to have some kind of fixed validator function that confirms it's an actual fixed message. But the most simple version of that is a membership test. So when we say a membership test, what I could do is, so when we start the for loops, so we're pulling in each line. So first iteration, it's going to pull in that first line. Let's check the line and see whether it's an actual fixed message before we get doing all this stuff. So a simple way we could do that is we could have added, I don't want to mess up this. We could have added a, let's say, hopefully you can see this. We could have added a if fix in line. So what we're doing is we're saying if the string fix exists within the line, then it's a fixed message. So then do all this stuff. So if you have a line that just says hello world, for example, you're not going to do this stuff. So you're only going to do this parsing if you verify that it's actual fixed message. That's something else you can do. Another thing to consider is, again, getting a little bit more advanced. So whenever you are creating all of these things, so for example, we did all the splitting. The splitting creates a lot of temporary string objects. So what's happening behind the scenes, like again, a lot of people, they write the code, but do you understand what the code actually means? So whenever we do the stripping, it's creating a lot of temporary string objects because strings are not mutable. So we basically are recreating, whenever we change it, we're recreating a new temporary string object. So you have to always consider that. So what is the relevance? In high frequency trading, if you're doing an operation where you're processing thousands of lines or lots of data and you do a split on it, you have to realize that you're creating a whole bunch of temporary string objects in memory, so that can create what's called memory pressure.
In HFT environments, memory pressure can kill performance. Let's do the math. A typical fix log with 100,000 messages contains 20 fields, each creating 2 million string objects during parsing. A roughly 40 bytes per Python string object. That is 80 megabytes of temporary objects. In a production environment processing millions of messages per minute, these temporary objects trigger frequent garbage collection, causing microsecond level latency spikes, deadly in HFT, where every microsecond counts. This is why professional HFT systems often use pre-allocated memory pools and zero copy techniques to avoid these allocation costs entirely. If you want to learn more about these concepts, comment below and let me know and I'll do a video.
So when you get into high performance, this is something that you need to be paying very close attention to. You need to understand that so that when you write this code, you know what it's doing, you know the risks, you know the dangers, and then you can accommodate them in some smart way. So that's one thing to consider. Another thing in terms of high performance, this right here is really sloppy. I did this really simple so it's easy to understand, but this from a high performance, if it's just a basic fixed parser, this is fine, nothing's wrong with it really. But in terms of high frequency trading production environment, this is very sloppy and inefficient. And I'll tell you why. There's so many reasons why, but one of the big reasons is that, let's think through this logically. When you're dealing with high frequency trading, you're dealing in the world of microseconds, picoseconds. Things are happening in the blink of an eye. So many operations in the blink of an eye, less than a blink of an eye. So think about this. You call this function, and this thing starts this whole process. Remember we said big O, M times N. The time complexity is the amount of lines times the amount of tag value pairs per line. So this thing, it's almost like you're getting on a one of those roller coaster rides. That's what this is the roller coaster. Once they put that thing down and the thing starts moving, you're committed. Once you start this function, you are committed, you're locked in. So if you don't like this and you feel uncomfortable, you feel nauseous, sucks to be you, you're stuck on this ride until it's done. That's a core concept. What I mean by that is, this is gonna start sucking in lines, processing the tag value pairs over and over again, sucking a line, new line parse, new line parse, new line parse, new line parse, new line. While you're doing this, the caller of this function is sitting there waiting. What's going on, guy? You got what's up?
You got anything? Like, what's up? What's taking so long? What's taking so long? What's taking so long? What's taking so long?
So let's imagine that this parser, the purpose of this parser is to take these fixed messages and send them over to some kind of GUI application that's giving you certain calculations on your average prices, how many orders are coming in, or some kind of detail like that. So while this thing, let's say a whole, high frequency trading, right? Thousands of lines come in all at once, right? Whole bunch of lines come in, and this thing starts going and processing line by line, line by line, line by line, line by line. While that's happening, you're not getting any updates, right? You have to sit there and wait until this whole thing is done before you get any updates. So visually, with the way that might look is you look at your screen and nothing's happening, the quantity just spikes. That's because your function just completed and it delivered all this new data, and now your GUI's able to see it. let's be more efficient. Let's be more high performance. So in a high frequency trading environment, one of the key modifications I would do to this is I would use something called yield. Yield sounds opposite of what we want. You think yield is like stop in the name of law. So yield, what yield is going to do is basically yield is going to allow you to sort of stream the results in real time to the caller. So what it is I grab a new line, right? I break it up by the delimiter, okay? I loop through each tag value pair, split them by the equal sign. Okay, cool story, bro. And then I grab item 1, 35, item 2, D, and I put it in a dictionary, and I keep doing that. Now I have a whole new dictionary. Now, the sloppy way is I take this list, I take this dictionary, and I insert it into the list that we created. But remember, this is all local. The caller of this function is out of the loop. They don't know what's going on. They're just sitting there waiting, like, where are my fixed messages, right? So instead of us inserting it into a local data structure, the log list, what we can do is yield that message to the caller. So now look what happens. Because we do that, as soon as you parse a message, instantly that message gets yielded back to the caller. So the caller is able to say, I like this, I don't like this, or maybe I want to do a categorization. Maybe you're using object-oriented programming, so you have a classifier that is able to recognize orders versus executions, and maybe you have a certain data structure that you're using to store all the orders versus whatever it is you're doing. So as soon as you get that message, you can choose to discard it. I don't care about this, I don't need it, or you can categorize it.
Well, let's dive a little deeper in this yield concept and what we're talking about building here. So this basically is a generator. Generators transform how we process large data sets. Instead of the roller coaster ride where you're locked in until completion, generators create an on-demand data pipeline. The three benefits are constant memory usage regardless of input size, also immediate processing of early results while later data is still being parsed, and the third benefit is cancelable operations. If you only need the first 10 messages, you don't process the rest. Here's a real-world example. Parsing a 2 GB fixed log with a generator uses a constant 5 megabytes of memory versus potentially 2+ gigabytes with our current approach. Always use generators when processing data streams of large files. Have you used a generator before? If so, comment below. I'd love to hear about it.
So think about it, you're operating parallel. So while this thing is parsing, as you're parsing, you're tossing the result of the line over to the caller. So new fixed message, boom, here you go. New fixed message, here you go. So while you're doing that, I'm working in parallel. I'm like, okay, hey, this is a new order. Let me put this over here. And while I'm doing that, your new line, boom, send it over. So think about that operation and how much more efficient that is. We're working in parallel, the caller and the function working in parallel, as opposed to the caller says, I'm calling this function, parse these messages. And I'm sitting here waiting, this over and over again, new line, waiting, new line. That's inefficient, right? So we want to use a yield so we can stream it over to the caller so we can get a more real-time response. Now, the other issue with this, a massive issue, and actually that kind of circumvents that, is if you're putting this whole thing into a log. Now, we started out pretty good, little bit of potential memory pressure issues with the temporary string objects, okay, fine, whatever. But still, line by line, lazy iteration. We're not putting the whole thing in memory. But you know what we're putting in memory, though? The list, the log list. Every iteration, we put a new dictionary in that list. So it's going to be growing and growing and growing and growing. And at the end of this, when this thing is done, that list is going to contain every single message. Now, in a production environment, high frequency trading, fixed logs could be gigabytes, in size. So you are storing a gigabytes large file. I mean, it's not in a flat file format. So I don't know what the space would be in this format, but you're storing a lot of data in memory. So that is a potential issue. But again, if you're streaming it with yield, you can avoid that. But otherwise, the way I can deal with this is there's different methods. You have something called chunking or memory mapping. I'm not going to get into too much details. I want you to look into those things. I'm just pointing you in the direction. I gave you the core knowledge here on how to build a parser. And now, as far as the advanced concepts, I'm leaving that to you. Look up memory mapping, look up chunking. So the basic idea with chunking, for example, is we can break things up into chunks. So I have a 5 gigabyte file. In my code, I designate the chunk size. The chunk size could be something that is scalable or adjustable, variable, so we can actually adjust on the fly based on system resources. So the chunk, basically, I'm going to deal with 100 megabyte chunks or whatever it is. You're going to break it up into pieces so you never have the whole thing in memory. So that's one of the strategies. Now, beyond that, the other thing that we didn't do is a try except block. You always want to have good exception handling. What if the file wasn't available or the file was corrupted or you don't have access to the file, right? So all of these operations should have been embedded in a try block. So we try to do all of this. And if we fail, then I have, instead of it crashing, you have exceptions, which says file not found exception, for example. You have, the various types of exceptions that you can have, and you can control if you run into this problem, do this. You run into that problem, do this. If you don't put that stuff in there, again, it's just going to crash. Oh, this file I found. Okay, boom, it explodes. So you want to have try except blocks in your code. You want to have a good doc string, which explains what the code is doing, so you can understand what your own code is doing in the future, as well as your colleagues. They want to understand how your code works. Comments, don't put too many comments. There's a sweet spot. Put comments, where they're necessary. For example, I might put a comment here and say, for the dictionary insertions, that this is not compatible with repeating groups. So just so somebody knows, somebody else looking at this, they're aware that this code will not work with repeating groups. A little note right there. And notes, you just put a hashtag or the number sign. So I think we've covered all of the basics. Now, the other thing with high performance is we would want to make this a modular, and it depends on what you're trying to do, right? But I want to make this a modular thing. So what I would do is I would create multiple, so I would use the multi-threading and make this a multi-threaded application, and I would have like a main process, and then I would have a listener process. I would have a resource manager process, and these would all be separate Python scripts. You might have one for the GUI. And also logging, by the way. You want to make sure you have good logging in this script. So this is how this could work, theoretically. The main process is the orchestrator. That is what is orchestrating everything, managing everything. That's a central process. The listener process is listening for new updates from the file that we're monitoring. And you can do something called polling. You can listen for events from the operating system. So there's ways to do that with Python, where you can actually listen. So when there's an event in terms of the file writing, the file is being written to, you can listen to the operating system and be able to tell, oh, the file's been updated. So that's all you're doing. You're sitting there listening on a separate thread for new updates. And new update comes, you let the main process know, hey, there's some new lines that need to be processed. And this can initiate the parser function. So here's our parser function. It can call that into a separate instance. So the parser function goes and grabs the latest lines and starts processing. Now, in a high frequency trading environment, there could be so many lines, thousands of lines. So I might want to scale this up and say each of these parser instances can only handle 5,000 lines at a time. So what happens is, once this parser is at capacity, the main process can detect that there's more lines and this is capacity, so it can spawn another instance of the parser. So we can have multiple parsers running in parallel. Now, it's not really in parallel because we're using Python. So Python, we have a constraint called the global interpreter lock. So basically, but actually this kind of circumvents it, because the global interpreter lock is basically you can only have access to the interpreter like one thing. So you can't, even though you can do multi-threading, you can't actually do things concurrently. Each instance has that kind of constraint or limitation. So I'm not 100% sure on how this would work, because this actually might be able to circumvent that. Because again, the limit is per instance. So two of these could potentially run in parallel. But once you start getting into really high performance, That's when you start wanting to get to like a hybrid model where you might want to use Python for the parsing logic, some of the parsing logic, some of the business logic, but then some of the stuff that is more, your bigger bottlenecks, you could use Python. That's something else to look into, Python, or you could better yet use a compiled language, which gives you much more access to performance advantages. And then you start getting into things like kernel bypass, where you're actually communicating directly with the network card. So the fixed messages come in, you have these new packets coming in, you bypass the OS kernel and have that data go straight to your application or space and memory that your application is looking at. So you get performance advantages there. Extreme performance, you're talking about FPGA cards, which are basically custom computing hardware, best way I can describe it. It's like you're building your own sort of processing device. Now that's getting really, really extreme outside the scope of this particular video. So I think we have covered it all. Any comments or questions or suggestions for the next video? Comment below and let me know. And again, click on the like button. This is Carlisle Speaks Wall Street, and this is how you parse a fixed message using Python. Not just fixed messages. This is how you parse a text file. We could have used the same things to parse any text file, pretty much. This is how you do it. This is how you do it. All right, guys, thanks for watching. And until next time, remember the first step in learning is always to smile. And that's exactly what you do right here on Carlisle Speaks Wall Street, where learning is fun. Thanks for watching.